Greetings, Grade 12. Today I'm going to be teaching you about topographic maps. As you learned from your grade 10 and 11, you learned that a topographic map is a map which shows features on a scale of 1 is to 50,000. So this scale represents that 1 centimeter on the map is equals to 50,000 centimeters in real life or on the ground.
Today, I'm gonna do a revision focusing on conventional sign, contours and landforms, cross sections, vertical exaggeration, and intervisibility. The first thing which you're gonna focus on is conventional sign. Remember what a conventional sign is. It is a standard sign used on a map to indicate a particular feature. It may be a letter of the alphabet or it may be a symbol. Let's recap on the different types and different colors of conventional signs. Firstly, there are three types of conventional signs. Point symbols, which is a trigonometrical beacon, line symbols, which is a power line, area symbols, which is a orchard. Then, as you can see, let's look at a few colors of conventional signs. We found that there's brown, which represents land features like contour lines. Then there's blue, which represents water features like dams. Then there's green, which represents vegetation features like cultivated fields. After talking about our conventional signs, now we are going to look at contour lines. If you remember, contour lines are brown in color, as you can see over here. See that they join places of the same height from this area to that area. We find that the space between our contour lines is called a contour interval. As you can see over here, this space is our contour interval. On a topographic map, a contour interval is always 20 meters.
Now I'm going to explain to you and show you the landforms which we can identify using our contour lines.
You see these contour lines, they are close to each other. You can see that they represent a steep slope. Then these contour lines, which are far apart from each other, represent a gradual or gentle slope. That's how we use our contour lines to identify the types of land features.
Now, from our contour lines, I'm going to teach you how to draw a cross section of a 1 is to 50,000 map.
We are gonna use these contour lines to draw our cross section. These contour lines are an extract taken from a topographic map. This is not any different from drawing from the topographic map. So remember one thing, before drawing a cross section, you'll need a piece of paper and a ruler. So now let's start to plot down our points. Now we want to find our cross section from point B, which is over here, then to point A, which is over here. Now you take a ruler and draw a straight line from point B to point A, because that's the cross sections which we are gonna draw. After doing that, take your piece of paper and align it next to your line drawn by a ruler, for example like this. Then every point which is touching your contour line, you will have to mark it off. Now that we have aligned our piece of paper with our straight line from point B to point A, right now we are gonna mark off the points which touch our line. For example, we are starting with the point of the contour line from point A, which is 140 meters above sea level. Then we write down its height above sea level. Then we mark off the flowing contour line, which is 160. Then we do so on for the following one, and then the next one we do the same thing. We mark it off, then write its height above sea level. Then we'll do this for all of the contour lines which touch our point A to point B or point B to point A, up until we are done with all of them which touch. Then after that, seeing that we have marked off all of our points which touch our point B from point A, we then now go to our graph and draw a cross section. We're gonna use this graph paper to draw our cross sections using the points which we marked off on the paper from our contour line. Then before drawing our cross section, we must first look at the vertical scale which we are given. For example, over here we're given a vertical scale of 1 centimeter represent 20 meters. What we are gonna do is write down the points with the interval of 20 meters. For example, for every centimeter, there has to be an interval of 20 meters. For example, seeing over here, there's an interval of 20 meters. This is a point of 120, 140, 160, 180, 200, 220, and so on. But if you notice the pattern, there's an interval of 20 meters because we're given that vertical scale. Then going to our horizontal scale, on the topographic map, our horizontal scale is always 1:50,000. After doing that, we are gonna put that piece of paper which we use to mark off our contour lines so that we can mark off the points where every point touches. We align it on our x-axis. Then after doing that, we are gonna mark off each point according to the height above sea level it has. Mark off our contour lines which touched our paper which we marked off our point. We do this by using the x-axis, the point on the x-axis which corresponds with the number on the y-axis, and we mark a dot where they meet. For example, let's start with 320. We jot down a dot, then go to 300. We jot down a dot where they correspond with the point. Then we do that for the following contour lines up until we are done with all of them. We'll go to 220, then jot it down, 200, jot it down, 180, jot it down according to the number or dot it represents or corresponds with. Then we'll go on up until we are done. After that, we'll draw a line freehand because this will represent our slope form. Remember one thing, you must not use a ruler to do this, otherwise it won't represent the true form of the slope.
Now that we have drawn our cross section, we are going to calculate the vertical exaggeration using that same cross section which we draw.
Before we move on how to calculate vertical exaggeration, we first have to understand what is it. Vertical exaggeration refers to the number of times the vertical scale of a cross section is bigger than the horizontal scale. To calculate vertical exaggeration, we need to divide the vertical scale of the cross section by the horizontal scale. The horizontal scale on a topographic map is always 1:50,000. The vertical scale is the one given on the cross section which we last drew, which is 1 centimeter equals to 20 meters. Before doing that, we need to convert those 20 meters into centimeters by multiplying 20 by 100, which will give us 2000, meaning that our vertical scale is 1:2000. Now, the formula of calculating the vertical exaggeration is VE equals to VS over. Now let's put in the values. 1/20 is our vertical scale. Then we divide it by 1/50, which is our horizontal scale, which we then fractionalize it, which is 1/2000 times 50,000 over 1. Then it will give us 25. This scale or cross section has been exaggerated 25 times. We are going to look at intervisibility. What is intervisibility? Intervisibility refers to the ability to see one point from another point on the landscape. Basically, it's having direct line of sight from one point to another. For example, using this cross section, we are gonna see if this point B is visible from point A. We say that it's visible, so it's intervisible. So using the next cross section, we are going to see if point B is visible from point A. We are going to draw a line across. We see that there's an obstruction. It means that it's not intervisible. That's what intervisibility is. Thank you.
Now that we are done with our lesson, we talked about conventional signs, contours and landforms, and we also learned how to draw a cross section. We also calculate the vertical exaggeration in order to find out how much the vertical scale is bigger than the horizontal scale. Now we also talked about intervisibility. Now, with that, you must keep this information with you because it may come in your final exams, because these are the skills which are needed for you to pass your exams and to answer certain questions in your exam papers.